Hello, this is our video over the carbon cycle, and this is our final content video for the semester. So remember, just briefly, the Earth is an open system. We have an exchange of matter and energy with the space around us, right? We get that energy from the sun, and then we actually radiate energy back out into space. We also, receive matter from space too, but we don't receive a lot, right? And so whenever we use these important elements like carbon and oxygen and nitrogen, we can't count on things out in space to replenish those atoms for us. So we need to go through these processes called biogeochemical cycles, right? And remember, the bio, the geo, and the chemical mean that we have the living biosphere participating, we have the lithosphere, the atmosphere, and the hydrosphere participating. And then these are, chemicals that are substances to Earth survival, and they are cycles because these materials are recycled throughout, and they start in a reservoir and they end in a reservoir, no matter how the movement of that cycle goes. Okay, and so today we're going to talk about these again in 5 parts. We'll talk about carbon in their reservoirs, in the movement of the cycle, the environmental problems of the I'm sorry, the causes of the environmental problems and disruptions of the carbon cycle, the effects of those disruptions, and then the chemical reactions that are involved. And so, it's important as we talk about carbon reservoirs to understand some terminology that goes along with that, right? So, carbon is super important because it is the central element to organic chemistry. We will talk about carbon reservoirs as carbon sinks and sources, right? So, if more carbon is entering a reservoir than leaving it, we call that a carbon sink, right? We're sinking carbon into there. If we have more carbon leaving a reservoir than entering it, we call that a carbon source, right? It's a source for that cycle. And so carbon reservoirs are pretty similar to the nitrogen and oxygen cycle. It's the atmosphere, the oceans, the geosphere, and the biosphere. And so you can see here's a brief little graphic over the carbon cycle that we'll continue to refer back to throughout this. Okay, so the carbon is found in the atmosphere in gaseous carbon dioxide or CO2. Uh, the ocean has carbon in 2 places. It can be dissolved carbon dioxide, much like water is, right? We have that dissolved gas in there. It's also a big component of shells that are found in the ocean, right? That will be calcium carbonate. And so those shells will break apart and weather down, and that allows the calcium to be incorporated into the ocean floor as well. Okay. In the biosphere, in the living things, carbon is the central atom of organic chemistry. And so that's in our DNA, our proteins, our molecules, everything. And when we remove water from our body's composition, you're about 50% carbon by weight. And then plants and animals, we die and introduce our carbon containing compounds into the earth, into the geosphere. And then in the geosphere, we find carbon mostly in calcium carbonate, which is limestone, and other carbonates below the Earth's surface. We also have fossil fuels that have formed mainly of carbon chains down there and carbon heavy compounds. And then we have things like diamonds and graphite that are also like pure carbon and part of that geosphere. And remember, we call those things allotropes of carbon because they're pure carbon just in different forms. So, one of the ways that we remove carbon from the atmosphere, we have 2 ways we do this. The one way is through photosynthesis, right? Uh, Plants take in energy from the sun and they take in carbon dioxide gas and turn that into, um, you know, oxygen and sugars. And then we have our other way that we remove carbon dioxide from the atmosphere, and that is where carbon dioxide is dissolved into cold water. All right, so that's 2 ways that we take carbon dioxide out of the atmospheric reservoir. We add or release back carbon into the atmosphere in a lot of different ways. Right, when we breathe, we're breathing out carbon dioxide. Um, we also have, decaying animal and plant matter, right? Fungi and other bacteria will break down the carbon containing compounds in our bodies and release that carbon as carbon dioxide sometimes. Um, Other times it'll be released as methane, right? It depends on if the process is aerobic or anaerobic. Aerobic means oxygen is necessary and present. Anaerobic means it's not, right? Then we have combustion, where we burn typically like fossil fuels, right? So we're putting things like methane and carbon monoxide and carbon dioxide into the air. And then in warm water, that carbon dioxide becomes harder to be dissolved in the water, and so it will come back out of the water. Okay. Carbon can be removed from the biosphere in a couple ways, right? We remove that biomass through like forest fires and wood burning. We burn fossil fuels, right? So we're taking that those fossilized things, those that dead plant organic matter from millions of years ago, and we're burning it for power and for our cars and things like that. And then carbon can also leave the biosphere when organic matter is decomposed, right? And then we add carbon to the biosphere when organisms like us or other animals eat plants or other things containing carbon. And then we have bacteria and fungi that take in, or I'm sorry, that add carbon to the biosphere through the decay of dying things. Right. Then we're going to talk about the ocean. So the ocean can remove carbon, or sorry, how we remove carbon from the ocean is through the making of seashells, right? So we have phytoplankton, and what they do is they use carbon to make shells of calcium carbonate, and then those shells settle to the bottom of the ocean. Um, and when those photoplankton die, they're buried in there. The shells of phytoplankton and other creatures become compressed. They're buried, and they're often turned to limestone under that pressure of the ocean, and that helps to form a limestone layer down there. And we add carbon to the ocean when carbon dioxide is dissolved. So what happens is we go through a process of turning CO2 into carbonate or bicarbonate. That is a similar process to what happens in sodas, right? So there's an equilibrium reaction between uh, carbonic acid, which is H2CO3, and carbon dioxide. Whereas if you shake up a can of Coke and you open it, right, there's going to be a big release. That is the carbon dioxide being pushed towards that side of the equilibrium reaction. And then they get the carbon dioxide in there by using carbonic acid. They push it to the other side of that equilibrium. And so the same thing happens in the oxygen as well, or in the ocean as well. And then carbon is going to move through the ocean in various ways. We have sea life eating other sea life. We have that production of calcium carbonate shells, and then these things die. They sink to the bottom, and then they're just kind of smoothed out, and that carbon is added to the earth over time, right? Carbon is added to the geosphere, right? When we have that carbon dioxide slowly being added over time from the ocean into the earth and that limestone sediment there. And then, we have our stores of coal and oil and gas. And that happened a long time ago, where we have this organic matter that has decayed and sat there for a long time that forms these long carbon chains that sit there through, dinosaurs and vegetation and life that was there a long time ago. So that is how we handle the reservoirs here, right? Now let's talk about the disruptions. So humans cause many disruptions to the carbon cycle. Um, we use fossil fuels for transportation and energy purposes. Does it not only depletes the carbon reservoirs, but it also adds carbon dioxide to our atmosphere. So it doubly impacts the carbon cycle there. Same thing with electric power plants. We have factories as well that produce products using fossil fuels. And then we have deforestation and the burning of forests, which disrupt the cycle because now there are fewer trees to take in that carbon dioxide through the photosynthesis process. And now we've burned away some of that. So we've also added carbon containing compounds to the atmosphere there. So it affects multiple parts of that, right? And we can see the effects of our disruptions here because we can pinpoint where industrialization happened. So here are a concentration of carbon dioxide in the atmosphere in parts per million, and you can see we can trace these things through samples of ice cores in like the Arctic and Antarctic and stuff like that. We can look at what the carbon was in the atmosphere as it was frozen in those ice samples, and we can see what these carbon dioxide concentrations were. And you can see 1800 and 1900, we see a gigantic spike with the industrialization of our society, right? And so now you can see that we're almost double what we were in 1800. So that was in 2016. So it's gotten even worse. Uh, Again, this contributes to the greenhouse gas effect, just like the oxygen cycle did, right? We have that heat coming in from the sun, but then when we have carbon dioxide and methane in our atmosphere, we're going to have a lot of that heat retain and stay instead of being radiated back out. And so less heat leaves the planet than should, and so that causes the overall warming of our planet. We can see that here when we look at the data of global mean surface temperature, mean meaning average, right? And so you can see these uncertainty bars here. So our records weren't as good back in the day, like the 1800s, as they are now. So you'll see those uncertainty bars get smaller as we go through time. But you can see the average of these temperatures here, and what's really important is the 5-year running average, right? Which means like if we're looking at the average in 1940, that's specific to 1 year. But if we're looking at the 5-year running average, that means we're looking at 1940, 1939, 1938, 1937, and 1936, all averaged together. And that's what this thick red line is here. And you can see we have an overall increase in the global mean surface temperature, and that is because of our increased production of carbon dioxide and carbon containing compounds going into the atmosphere, increasing that global mean temperature through the greenhouse effect, and also, uh, I don't remember what I was going to say there, but that's our problem there. Yeah. So um, this is going to affect a lot of things. You've probably, living in Kentucky, noticed that it's already affecting tornado formation. Our tornado season is longer and more vicious. And so this video is on here. I'm not going to play it through our slides, but it goes through how tornadoes are formed. And I think it's pretty interesting. So take a look at that when you get a chance by looking at the slides.
Tornadoes occur on every continent except.
Okay. And so here we now have the carbon cycle chemical reaction. So we have photosynthesis up top, and then we have combustion and metabolism down below. That is in here.
Plants.
Botany video, and then we have
You and I began
a video from Crash Course about the global carbon cycle. So please take a look at all that. As you're watching this video, you will have a carbon cycle quiz that is due Monday, May 12th. And then you'll have your Unit 9 mastery test that covers all 3 cycles that will be due on the 12th as well. So thank you for watching. Thank you for a great semester, and good luck on everything.